Let's look at a buffer mixture. So, what makes a good buffer? It has equal concentrations of acid and its conjugate base. So, weak acids and their salts will have a buffer mixture that is at a pH less than 7. Weak bases and their salts will form a pH greater than 7. So here's an example of a buffer that's made with acetic acid and sodium acetate, and we want to calculate the pH of this buffer solution. So if we mixed equal molar amounts, 0.10 molarity of acetic acid and sodium acetate, what is its pH? So here is our hydrolysis reaction. Acetic acid interacting with water to form acetate and hydronium ions. This is our Ka for acetic acid. So we're going to set up an ICE table where we know the initial concentration of acetate as well as acetic acid. And if you calculate Q, you'll find that it's less than K, which is why the reaction is written, why we basically have the acetic acid being consumed, denoted by this minus X, and plus X on our product side. So we get our equilibrium concentration expressions. And to get the pH, right, we want to know what the concentration of our hydronium ions are. So using our Ka expression, we will find X, right? So when we do X times 0.10 plus X over 0.10 minus X, based on our Ka value, we can make the simplified assumption that X is pretty small compared to 0.10. So 0.10 plus X and 0.10 minus X is going to reduce to 0.10. So X is just equal to 1.8 times 10 to the minus 5. That is our concentration, right? X is our concentration of our hydronium ion. So if we take the negative log of this, we'll get a pH of 4.74. So this buffer mixture has a pH of 4.74. So if we want to measure the buffer capacity, right, what will happen if let's say we have 100 milliliters of this buffer, and we add 1 milliliter of a 0.10 molar sodium hydroxide, what will that pH be? So first, let's see what happens if we add sodium hydroxide. So it's going to neutralize the acid in a 1-to-1 molar ratio. So here I'm just showing the reaction of our acetic acid being neutralized by the sodium hydroxide. So to calculate the molar amount of sodium hydroxide that's added, we're just going to multiply the volume of sodium hydroxide that we add times its concentration. And we see that we have 1 times 10 to the minus 4th moles of sodium hydroxide. And then our initial molar amount of acetic acid is 1 times 10 to the minus 2. Right? So we know we had an initial concentration of 0.10 molarity, and we have 100 milliliter or 0.1 liters. So we have our initial molar amounts of sodium hydroxide and acid that is neutralized. So from there, we want to calculate how much acetic acid and acetate will be left over after it's neutralized with sodium hydroxide. So we're going to subtract the molar amounts of sodium hydroxide from our initial molar amounts of acetic acid and acetate. So here I'm showing us doing this for acetic acid. So this is our initial molar amount of acetic acid minus the moles of sodium hydroxide. So we have 0.99 times 10 to the minus 2 moles of acetic acid left over after it's neutralized by base. And the amount of acetate we have left over is 1.01 times 10 to the minus 2. So here we're going to add the amount of sodium hydroxide that is added to neutralize our acid. So we have our final molar amounts of acetic acid and acetate after neutralizing with sodium hydroxide. So now to get the concentrations of our acetic acid and acetate, we just take our molar amounts and put it over our total volume, which is 100 milliliters of our buffer plus the 1 liter of sodium hydroxide that we added. So we have our final concentrations of acetic acid and acetate. So now we're going to go back to our initial hydrolysis reaction to calculate the concentration of our hydronium ions after neutralizing with base. So I just have for reference here, this is our final concentrations of acetic acid and acetate after neutralizing with base. And now to get the concentration of our hydronium ions, we will just plug in the molar amounts that we have for acetic acid and acetate, and we plug in for our Ka value. So I basically just took our Ka expression, rearranged it to solve for our hydronium ion concentration, and we find that to be 1.76 times 10 to the minus 5. If we take the negative log of that, our pH is 4.75. So that's just a slight increase from 4.74. So we would say this buffer has a pretty high capacity when we add 1 milliliter of, what was our concentration of sodium hydroxide? I think it was 0.1 molarity. So we just see a slight increase in pH.